Bhramari Pranayama is a regulated breathing technique defined strictly by its biomechanics, a prolonged exhalation phase paired with a continuous, self-generated acoustic vibration. This basic physical input triggers a response of high complexity within the human systemic network. Clinical data consistently identifies statistically significant improvements across multiple bodily systems following this non-pharmacological intervention. These improvements span a broad spectrum, ranging from psychiatric metrics to localized physical healing of the respiratory tract. The efficacy of this practice is driven by two distinct measurable physiological pathways operating simultaneously. Analyzing these respiratory mechanics allows us to define the practice as a precise, quantifiable neurochemical protocol. Rigorous psychometric validation is required to study the impact of non-pharmacological breathing interventions objectively. The Pittsburgh Sleep Quality Index, or PSQI, utilizes these 7 clinical criteria to evaluate global sleep quality and latency. To quantify the psychological perception of systemic stress, researchers utilize the PSS-10 scale. Clinical pathology is tracked via the SNOT-22, the Sino-Nasal Outcome Test, which measures the severity of chronic rhinosinusitis symptoms. Patients practicing this humming breath show rapid, measurable improvements across these 3 distinct medical scoring systems. A valid physiological model must account for both these systemic psychiatric shifts and the localized healing of the sinus mucosa. At rest, respiration maintains a balanced ratio between inhalation and exhalation. Bhramari Pranayama shifts to a drastically prolonged exhalation phase. This inherently increases vagal tone through the cardiopulmonary linkage. The laryngeal anatomy is deeply innervated via the recurrent laryngeal nerve, a major vagus branch. This anatomical pathway allows for vagal afferent stimulation, sensory signals traveling from the periphery to the brain. The physical acoustic vibration of the vocal folds during humming acts as a continuous mechanical trigger for these vagal afferents. This dual trigger forces a deceleration of the heart rate and suppresses active cortisol production pathways. Combining prolonged exhalation with humming physically shifts the central nervous system into parasympathetic dominance. Experimental data from clinical trials allows us to observe these autonomic mechanisms in a controlled environment. A 2021 study by Kumar and Venkatesh evaluated a 6-week intervention in an adolescent cohort. This chart tracks pre- and post-intervention perceived stress scores, dropping by 33 to 37%. This represents a significant reduction in stress over a short intervention period. Parallel data in the same cohort showed corresponding sleep quality improvements according to PSQSI scores. Statistical analysis yields p-values of less than 0.0001, indicating these recorded shifts are highly unlikely to be random chance. These psychometric successes correlate with the sustained vagal tone and parasympathetic dominance established by the respiratory mechanics. While the vagal pathway accounts for the psychiatric data, a second biological model is required to explain the mechanical sinus clearance observed in separate trials. We now look away from the systemic nervous system to the localized mucosa of the upper respiratory tract. In this pathway, the humming vibration functions as a kinetic, acoustic, mechanical stimulus. This resonance radiates upward into the maxillary and frontal sinus cavities. This mechanical action triggers the endogenous upregulation of nitric oxide, or NO. As illustrated here, humming produces a 15-fold increase in nitric oxide generation compared to standard quiet exhalation. Nitric oxide is a potent local vasodilator. This spike in NO gas immediately regulates the filling of nasal capacitance vessels, expanding microblood vessels within the sinus lining. This vasodilation optimizes mucosal temperature and accelerates ciliary clearance. The vocalization effectively turns the sinuses into a localized nitric oxide generator. This on-demand paranasal nitric oxide spike has direct clinical implications. Trials have specifically evaluated patients suffering from chronic rhinosinusitis without nasal polyps. This graph tracks the SNOT-22 severity scores over 12 weeks, illustrating a progressive downward trend in symptoms for patients practicing the intervention. Statistically significant therapeutic divergence in symptom scores appears as early as the 4-week mark. Acoustic nitric oxide generation ventilates blocked sinus ostia and disrupts microbial settling in the paranasal cavities. This self-generated anti-inflammatory effect occurs without the compliance limitations and side effects often seen with conventional corticosteroid sprays. The 15-fold upregulation of nitric oxide accounts for the dramatic, localized healing observed in complex sinus pathology across these trials. These models merge to show how the human organism functions as a single system. A single humming exhalation triggers the neurological and biochemical pathways concurrently. The parasympathetic shift regulates systemic psychiatric markers like stress and sleep. Simultaneously, the localized vasodilation manages the physical mucosal load and clears inflammation. This dual pathway execution achieves complex physiological regulation without external pharmacological inputs. Evaluating Bhramari Pranayama strictly through the lens of modern clinical utility reveals its reproducibility as a therapeutic tool. This identifies a precise clinical utility for patients requiring low-risk adjunct therapies for insomnia, chronic stress, or sinusitis. The process utilizes a free, self-administered mechanical input to yield complex biochemical outputs. This outcome is driven by altered respiratory mechanics, acoustic paranasal resonance, and targeted nitric oxide vasodilation. Evidence-based health practitioners today can deploy this technique as a precise, verifiable modulator of human autonomic and biochemical function.